Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Trick Shot by Michael Lefkowitz, and here are the rules. We have Sudoku rules, but this is not normal Sudoku because this is only a 6x9 grid. But I like how he placed this. He said this. Place a digit from 1 through 9 in each cell so that no digit repeats in a row, column, or 3x3 box. And that fits that's the way that I normally say normal Sudoku rules. I probably shouldn't say normal Sudoku rules. I should just say Sudoku rules because in that sense it is still Sudoku rules, but it's not normal Sudoku because we don't have the entire 9x9 grid. It's a 6x9 grid. But anyways, we do have where we need to place the digits 1 through 9 in each cell with no repeats in any row, column, or box. Balls. Each ball, not including the white ball, has a different digit. So these are all different digits. Interesting. I wonder if these actually match the regular pool ball numbers. I'm hoping it does. I don't actually remember which one's which. I think... I want to say... It's been so long since I've played pool. Yellow is 9. So this should be a 9 here. So each ball, not including the white ball, has a different digit. So that's 1, 2, 3, 4, 5, 6, 7, 8. Is there 8 only? 1, 2, 3, 4, 5, 6. There's also there's solid balls and there's stripe balls. I know the stripe yellow is a 9. But I don't remember which one's the... I think yellow is also the 1? It's been so long since I've done pool, so I don't remember actually anymore. I didn't play pool that often, but it's interesting. But all we know in this puzzle is that each of these balls has to be a different digit except for the white ball. The white ball can be anything. We have pockets where each digit touching a pocket is double or half the digit by the pocket vertically across from it. Is double or half the digit? Oh, by the pocket vertically across from it. So essentially, these pockets act as like black Kropke dots, but across the other side of the grid. So each digit touching a pocket is double or half the digit by the pocket vertically across from it. Yes. So basically, think of essentially these pockets as making it toroidal vertically, and it's a black dot, so it's a black Kropke dot, so it's in a 1-to-2 ratio with the digit that is next to the pocket vertically away from it. So for example, say this was a 2. That would mean this digit is either a 1 or 4 to maintain the 1-to-2 ratio between them, right? Because they're both next to the pocket, next to a black dot, right? So that is how an example of how the pockets work. Again, think of them as black Kropke dots toroidally vertically with the cell that is next to the other one. The matching pocket, I guess I should say. And that's an example of how pockets work. We also have a line where we need to draw a straight line between cell centers, starting at the white ball, which bounces if it hits a cell on the edge of the table. Okay, he has an example, which is good. So if we have, say we have row 2, column 2, going to row 1, column 3. Oops, that's not an edge. So row 1, column 3. It would then bounce to row 2, column 4. Okay. The line must reach the 8 ball and then a cell with a pocket. Okay. Without crossing other balls. Oh, these must all be stripes then. Or they're all solids. Huh, that's good. They must be all be solids then. So it should be 1 through 7, technically. I don't know. It should be 1 through 7 because he's trying to hit the 8 ball and pocket the 8 ball into the corner. So with the 8 ball winning thing, that means all the other balls are essentially the other digits. I hope they actually match up, but that... No, I don't know. Adjacent digits. So they must be solid balls. So this is not a 9 here, then. Is it 1? Is 1 equal to the yellow? As a solid? I don't remember. It's been too long. Anyways. The line starts from the white ball and must reach the 8 ball. So it's like you're basically hitting like a trick shot. So you have to go some way around, going around to hit the 8 ball eventually, and you'll always bounce in if like a 90-degree angle. Oh, okay, well. You could do some... Well, that goes straight to the pocket, so that's not going to work. And... So it must reach the 8 ball. The path must reach the 8 ball. I've already sort of spoiled some of it. And then the cell with a pocket without crossing other balls. Adjacent digits along the line differ by exactly 1. Okay. So say we had this as part of the line. This could be something like, I don't know, 6, 5, and 4. And this would be valid because adjacent digits along the line differ by exactly 1. Anyways, and again, remember this cue ball must essentially hit the 8 ball so that it goes into a pocket. So it goes into a pocket, goes into pocket, somehow goes to a pocket here. Actually, could you go that? I don't know. Probably not. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Well, where can the 8 ball go into a pocket? Cannot go here because it's blocked by this ball. This purple ball, I believe. I don't even know. How would it diagonally go? It doesn't go that way. It has to go to a cell with a pocket. So yeah, and it's basically this one. So then you have to figure out what direction it has to go from the cue ball. It'll bounce this way. It'll bounce this way. To bounce this way. To bounce... Oops, not there. Here. Not there. To bounce that way. To bounce there. So this is the direction of the trick shot. This has to be 7 or 9. So this will give us odds and even digits, interestingly enough. This is 7 or 9. 7 or 9. We have 6 or 8 here. This is 6 or 8 here. So that's in a 1 to 2 ratio with this digit here. So this is 3 or 4. 6 or 8 leaves that 5, 7, 9. Leaves that 4, 6, 8. Leaves that 3, 5, 7, 9. Leaves that 2, 4, 6, 8. Leaves that as 1, 3, 5, 7, 9. 2, 4, 6, 8. 1, 3, 5, 7, 9. 2, 4, 6, 8. 1, 3, 5, 7, 9. 2, 4, 6, 8. 1, 3, 5, 7, 9. And this is 2, 4, 6, 8. we have a 2, 4, 6, 8 quadruplet in row 2. So the rest must be 1, 3, 5, 7, 9. So yeah, these are all even. So we're going to mark those as blue. The rest are all odd. Okay. So these must be all odd because we have 4 evens in the row. So these are odd. This can't be 8. So this can't be 9 here because it's either 4 or 6 here. 8 in box 2 has to be one of these 3 cells. None of the balls can be 8. So this cue ball can be, though. Okay. So this is 13579. This is 13579. Interesting. So 8 cannot be here. 8 has to be either here, here, or here. Okay. What happens if this is 3 and 6? If this is 3 and 6, all of these digits in box 2 must be even because we have 5 odd digits in that box. So this would be even. So we'd have 3, 6, and these would all be even, which would force this to be an odd digit because we'd have 4 evens in column 5. So then this would be odd. But if this is 4, 8, this would be a 2, 6 pair here. We'd have all the evens in column 5 already. So then these would both be odd. So either way, either this is an odd or this is an odd here. And either way, this is an odd here. So therefore, these are guaranteed to be even. One of these two is odd. This is always odd. Interesting. Seven. 2 has to be one of these two. That's not telling us much. So since 2 has to be one of these two, okay, that does tell us much. Never mind. Again, this goes to 8 to 7, 9. 7, 9 is only consecutive with 6 or 8, which is only consecutive with 5, 7, or 9, which is only consecutive with 4 or 6. So this is 4 or 6, so 9 cannot be here. This is 5 or 7. One of these is guaranteed to be 2. So this cell here has to be consecutive with a 2. So it cannot be 5, 7, or 9 here. This is 1 or 3. 1 cannot be consecutive with 2 unique digits. And these would both be unique digits. So this can't be 1. This is 3. Since this is 3, this can't be 3. This is 4 and 8. Which eliminates 4 and 8 in the rest of the column. So this has to be, this is an even digit. We have 4 even digits in column 5. So this must be odd. So this cannot be 3. No 3 here, no 3 here. So 3 is only consecutive with 2 and 4. So this must be 2 and this must be 4, which makes this 6 and this 8. The digits consecutive with 6 and 8, it's only 7. So this is 7, which eliminates 7 here. So this is 9. This is 4, 2, and 8, so this is 6. So 1's not consecutive with... 1 and 9 are not consecutive with 6. So this is 5 or 7. That means this can't be 2 here. This can't be 4. This is 6 or 8. The only digits consecutive with 6 or 8 are 5, 7, 9. So this can't be 6 or 8. It cannot be 2 because 2 is not consecutive with 5, 7, or 9. So this is 4, which makes this 5, this 7, and this 9. 5 and 7 are only consecutive with 6, so this is 6. This could still be 8 here. One of these two is an 8 here. This can't be 5, 7, or 9. It's 1 or 3. This digit is consecutive with 4, and it can't be 5, so this is a 3. This has to be 1, 5, or 7 here. This digit cannot be, it's either 1, 3, or 5. Remaining digits, 8 is here. So 8 cannot be this one or this one. These are 6, 8 as a pair. 9 is one of these two digits here, so this can't be 9. We have 1, 3, 5, 7. No 3 here. Where is 3 in row 2? It can only be here, so this is 3 here. This can't be 5 because of 5 in the column. Okay. 9 is one of these two digits because it can't be here, can't be here. So 9 has to be one of these three digits here. We have 4 and 6 remaining in row 5. 6 cannot be here. 4 cannot be here. So 4 and 6 both have to be in box 6. And obviously 6 can't be here. So 6 has to be one of these two. What are the remaining digits in row 8? Let's just do that. Or row 5. We have 1, 2, 3, 4, 6, 8. So this could be 1, 2, 3, or 8. This could be 1, 2, 3, or 8. We have 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. This can't be 6 because of 6 in the column. This can't be 3 because of 3 in the column. Okay. Remaining digits of... remaining digits of row 1. We have 9, 1, 2, 5, 6, and 8. Okay, this can't be 5 because of 5 in the column. This can't be 6 because of 6 in the column. 1, 2, 5, 1, 2, 5, 6, 8, 9. No 6 or 8. So this is 1, 2, 5, or 9. No 9. So 1, 2, or 5. Okay. We have 9 as one of these three. 1 out of 6 or 8 is there. If this were 8, that would force this to be an 8 here because we need an 8 in row 5 somewhere. And they would have two balls. Actually, this can't be 8 in the balls, right? So this can't be 8 and this can't be 8. Oh, okay. Which forces this to be 8 here. This is then 1, 2, or 3. Eight is one of these three then. Okay. Oh, these have to be in a 1 to 2 ratio with these cells. So 9 cannot be here. Also, it cannot be 5. So 1, 2 would be with 1 or 2. And then 6 would be with 3 in a 1 to 2 ratio. This can't be 5 because... So this must be either 1, 2, or 4 here. So we're guaranteed in this combination... Okay, remaining digits in box 3. We have 1, 2, 4, and 5. Okay. Um, Again, one of these two digits has to be a 2 to be in a 1 to 2 ratio with each other. So that eliminates 2 in the rest of the column. We don't know about this, though. Remaining digits in box 4. We have 1, 2, 3, 7, 9. Right? 3 cannot be either of these. Because of 3 in the column. 2, 3, 4, 3, 4, 5, 6, 7, 6. This could be 5 or 7. 6, 7, 8, 9, 8, 9, 8. Okay. 4 we know in row 3 has to be one of these two digits. Huh. Okay, Sudoku. Not including the white ball has a different digit. Each digit touching a pocket is double or half the digit. Differ by exactly 1, so that's done. Huh. Remaining digits in box 5. We have 1 through 5 here. Ah. 4 cannot be here or here. This can't be 3 or 3 because of 3 in the column. This could be 4 because of 4 in the row. Where's the 4 in box 5? It has to be one of these two cells, which eliminates 4 in the rest of the row. This can't be 4. Therefore, this is a 1-2 pair here, which eliminates 1 and 2 in the rest of the column. So there's no 1 here, no 1 here. Okay. That still doesn't tell us too much. Interesting. This is 1, 2 as a pair. Remaining... There's just so many remaining digits that could be. Anyways, let's continue. Remaining digits in row, let's do 3. 1, 2, 4, no 4. 1, 2, 5, 6, 7, 8. 1, 2, 5, 6, 7, 8. This can't be 8 because of 8 in the column. This can't be 6 because of 6 in the column. Row 4, we have 1, 2, 3, 5, 7, 9. And this can't be 3, 7, or 9 here because of 3, 7, 9 in the column. Row 6. I'm so used to the bottom row being 9. We have 1, 2, 3, no 4. It's 5, 7, 9. 1, 2, 3, 5, 7, 9. And this can't be 3, 7, or 9 here. Aha, that's where we get our thing. We have a 1, 2, 5 triplet in box 6, which eliminates 1, 2, 5 in the rest of the box. This can't be 1, 2, or 5. This can't be 1, 2, or 5. This can't be 1, 2, or 5. No 1, 2, or 5 here. Now we have a 3, 4, 6 triplet in box 6, which eliminates 3, 4, and 6 in the rest of the box. This can't be 3. This can't be 3. These are 7, 9 pairs. Okay. Huh. We have a 1, 2, 3, 4, 5 quintuplet in row 6, which eliminates 1, 2, 3, 4, 5 in the rest of the row. So this can't be 1 or 2. It's 7 or 9. We have 3, 4, and 6 here. We have a 3, 4, 6 triplet in row 5, which eliminates 3, 4, and 6 in the rest of the row. So this can't be 3. This is 1. This can't be 1 or 3. It's 2. So that means this can't be 1 here. That also eliminates 2 in the rest of the box. So if this is 1, this is 2. If this is, and this can't be 2 because we already have a ball with the number 2. It can't be 1 because this can no longer be 1 and 2 as a pair, so this must be 6. So this is 6, this is 3. That eliminates 3 in the rest of the box and row. So where's the 3 in box 5? It has to be here. So this is 3. We no longer have a 1 available in box 5, so these are not 1. This becomes a 5, 7 pair in box 2, which eliminates 5 and 7 in the rest of the box. So this can't be 5 or 7. This is a 1, 9 pair in row 2, which eliminates 1 and 9 in the rest of the row. So this can't be 1. This is 7. This can't be 1 or 7. It's 5. We can't have 5 or 6 remaining in box 1. So no 5 or 6. No 7 either. So this is 1 or 2 here. This can't be 5. This can't be 5. So this is 4. That eliminates 4 in the rest of the column and row. We have a 1, 2, 1, 2 pair in box 3, which eliminates 1 and 2 in the rest of the box. This can't be 1 or 2. This is 5. This 5 eliminates 5 in the rest of the ball, so this can't be 5. That's 7. 7 eliminates 7 here, so this is 5. This can't be 5 anymore because of 5 in the column. We have a 1, 2, 1, 2 pair in row 3, which eliminates 1 and 2 in the rest of the row. This can't be 1 or 2. It's 8, which forces this to be 6, forces this to be 8. That means neither of these can be 8. This 2 eliminates 2 here in the column. 7 eliminates 7 here in the column. 7 eliminates 7 here in the column. So this is 9, this is 1, this is 7. This 9 and 1 eliminate 1 and 9 here, so this is 2, which eliminates 2 here, so that's 1. So this can't be 1, that's 2. 9 eliminates 9 in the rest of the row, so this is 7, which eliminates 7 in the rest of the box, so this is 9. This 1 eliminates 1 in the rest of the box, so this is 9. 2 eliminates 2 here, so this is 1, which makes this a 2 to be in a 1 to 2 ratio. So 2 eliminates 2 here, so it's 4, which makes this not 4 or 2, so this is 5, which makes this 2 here. 1 and 2 eliminate 1 and 2 here, so it's 5. 5 eliminates 5 here, and it can't be 2, so this is 1. 6 eliminates 6 in the ball, so this can't be 6. This is 4, this is 3, this is 6. This 9 eliminates 9 here, so that's 1 and 9. And are those the colors of the ball? I think so, actually. Red definitely is 3. I do remember that. 4 is purple. Or whatever that is. I think this was magenta. 3 is red. 2 is blue. That does seem right. 6 seems green. That seems right. Well, we can just look it up, I guess. Yeah. Pool balls. We have, right. 1 is yellow, 2 is blue, 3 is red, 4 is green. Wait, is that green? It's purple. 4 is purple, 5 is orange, 6 is green, 7 is sort of magenta. So that does actually fit. Nice. Well done. I mean, obviously we could have done that if we figured that out, but it was nice to see that. So the stripes wins then with this puzzle shot. Very cool. Very nice. Anyways, I hope you enjoyed this puzzle, this solve. And I'll see you next time on Frank Puzzles. Take care.